Welcome back to today's video. Today we are diving into two essential topics into data analysis and machine learning. That is multicollinearity and principal component of analysis. So these component concepts plays a critical role in building robust, interpretable statistics models. So by the end of this video, you will understand their theoretical foundation and see how to implement them in Python program. So let's get started. So before jumping into the code, let's start and let's first understand why we care about multicollinearity and PCA. So in regression analysis, we often work with multiple independent variables to predict a dependent variable. Multicollinearity occurs when some of these independent variables are highly correlated with each other. This means they provides overlapping or redundant information which can complicate our analysis. So principal concept analysis PCA. On other hand, PCA is a dimensionality reduction technique. It helps us to simplify data sets with many variables by transforming into a smaller set of uncorrelated variables called principal components without losing significant information. So multicollinearity, more formally, it occurs when two or more independent variables in a data sets are highly correlated, meaning they have a strong linear relationship. So, for example, if you are analyzing house prices, variables like square footage and number of bedrooms might be highly correlated because large house tends to have more bedrooms. So, why is this problem? Multicollinearity leads to unreliable regressions coefficient. It makes it hard to understand which variable um, which variable actually influencing the dependent variable. More the standard errors of the coefficient increases, which makes hypothesis testing less reliable. So we use two primary tools to detect multicollinearity. First is correlation matrix and variance inflation factor. So correlation matrix, this gives a pairwise comparison of variables showing how strongly each pair is related. Whereas VI, this matrix con this matrix quantifies how much the variance of a coefficient is inflated due to multicollinearity. A VIF above 5 is concerning and above 10 is critical. So, what is PCA? A statistical technique that transforms high dimensional data into a lower dimensional form. It does this by finding new variables called principal components that are linear combination. Now, how it works? PCA starts by standardizing the data to ensure all variables contribute equally regardless of their original scale. And then we calculate the covariance matrix by understand how variables vary together and finds the eigenvalue and eigenvector of the covariance matrix. These find direction and magnitudes of new components. Benefits of PCA are PCA helps defining, simplify the data analysis. It eliminates multicollinearity by creating convoluted data. PCA is also a great visualizing high dimensional data in 2D or 3D. So now practical application of PCA. First is data visualization. Data visualization is a high dimensional data set like customer demographics can be visualized effectively by reducing them to or three principal components. Feature extraction, machine learning's model often benefits like from PCA as it selects the most important features, improving models performance and interpretability. Noise reduction. by retaining only the components with significant variance, and pattern recognition. So this is how we can generate PCA. So for applying this in Python code, first we will standardize the data, then apply PCA, and then we will visualize the principal components and explain the variance. So let's recap this. So what we learned that is multicollinearity can distort regression model, and VIF is a useful diagnostic tool. PCA reduces dimensions while retaining critical information, where PCA helps in data visualization, featuring extraction of machine learning, noise reduction datasets. So thank you for watching. See you in the next one.